Hey everybody, let's go over how mass and volume affect density, and let's look at this table. The first question is, what happens to density when you increase mass? Will the density increase or decrease? So first, let's go ahead and plug in numbers. So I'm going to do initial, and let's say that your mass is 1 gram, and your volume is going to be 1 centimeter cubed. So if we put that into the density equation, it's just going to be 1 over 1, which is going to give you just 1 grams per centimeters cubed. But now you want to see what will happen if you increase the mass. So I'm going to do final, and let's increase the mass to 2 grams. So now instead of 1, we increased it to 2 grams. The volume it stayed the same. And so now I'm going to put it into my density equation. So for M, I'm going to put 2 grams divided by 1 centimeters cubed, which gives me a total density of 2 grams per centimeters cubed. As you can see, the density did increase. So here I'm going to put increase. Now let's look at the second one. What happens to the density when you increase volume? I'm going to keep my initial values for density the same, but now I'm going to do a different final value. So I'm going to do final volume. So in this problem, I'm going to assume that my mass and my volume are staying at 1, but now let's increase the volume to 2. So mass equals 1 gram, volume equals 2 centimeters cubed. And now let's plug that into the density equation. So I get 1 gram for M, and then I'm going to put 2 centimeters cubed for V, which gives me half grams per centimeters cubed. And now when we compare that to our initial, we're basically going from 1 to a half. So that means that your density decreased. I'm going to go ahead and put decreased. And that's it. That is one way that you can figure out the effects of mass and volume on your density.